This visualization was carried out in processing. This is a novel visualization showing the transformation of algorithm performance data using a novel metric. The novel metric's aim is to expose patterns in the performance data by keeping the structure of the data the same, but by taking advantage of the whole space. Two important questions this visualization aims to answer are, is the rank maintained? As you can see, on here is the raw performance data. Each color represents the best performing algorithm. This line that splits the box in the middle is the split between each algorithm performance space. If an instance was to cross over this space, its color will change. The second question that needs to be answered is the data going to be spread out enough? Currently, the raw performance data is very clustered to the top performing area. This is not ideal, and the data should be spread out across the whole space. So I'll press the Go button now, and it'll show the animated trajectory of the translation. You can see here the data is starting to be spread out. This is a 3D visualization, and the box can be rotated to show it in 3 dimensions. This is a 90-degree button, which just allows you to compare in a 2-dimensional way. Each instance here can be selected to find out its actual numeric data. Up in the top left corner, the numeric data is now displayed. You can see the instance that's been selected is highlighted in white. For 2 rotations, it will be displayed in white, and for 2 rotations, it will be displayed in blue. This was done because when you're rotating it, you can forget which was the best performing algorithm for your selected instance. So I'll show you here under rotation, it changes to blue to remind the user, and then it changes back to white to allow for easier viewing. Now I'll show you the raw performance space. This was where the data came from. You can see that the selected instance is still highlighted. This can be unhighlighted by just selecting off the screen. Then I can show you this is where the data spread out to. This is the final space without any trajectory shown. I'll show you the paths here. Now, this is only 20 instances, but this metric was used on 1.8 million instances. So the user might want to see more instances displayed. They can do this by entering any numeric number on their keyboard, and this will be displayed in the number of instances. For example, 500, and I press enter on the keyboard, and the visualization is done with 500. If you don't want to see the motion trajectory, you can just click to the final thing, and you can rotate around. This is the final position of the metric's values. This visualization had quite a lot of challenging aspects, such as actually clicking on the data itself. It's a 2D click transforming to a 3D space. This means the data has been offset by depth, and you need to take that into account when you're clicking on the visualization. Another difficulty of this visualization was that the rotation of the axis had to be translated. As each axis was moved, the actual axis had to be translated with the rotation of the box. So for the results of this visualization, they were very promising. It's quite easy to see if any instance has crossed over the final line. It's also quite easy to see that the data has been sufficiently spread out to allow for a lot easier clustering of the data. Thank you.